Welcome back to the Rule Your Pool podcast, everybody. This is episode 77. And for the second time in a row, I would have said 7th, but I did some episodes without Jared. We had to reset the counter. But Jared is with us once again, fans. Jared.
I'm happy to be here, and I must point out, everyone, if you're watching the YouTube, Eric and I are wearing the exact same shirt today.
Twinsies.
I love being a twin.
Yep.
Everybody, really, I am a twin, though.
He is. He has an identical twin brother. It's crazy. Maybe we'll have him on the podcast one day.
Oh, there's your next co-host. When I'm not available, I'll just tell Jake to come on.
That's perfect.
No one will even know the difference.
Jake doesn't even know we have a podcast because you don't even listen to it.
It's true.
What chance does Jake have? All right, a little bit of housekeeping like we did in the last episode. As a reminder, we are doing Swim Across America September 24th. We are 2 months out right now, or actually less than that. If you would like to donate, it's totally anonymous. We don't get a penny of it. It all goes to cancer research. It's for a great cause. We are honoring our fallen employee, Kelly. She meant a lot to us, and we lost her in just a few weeks to cancer. It was tragic. It was a tragic way to start the year. And if you remember, a couple months ago or a couple weeks ago, whatever it was, there was a study done with immunotherapy, and it was the first time that it was 100% remission on cancer. And that was initially funded by Swim Across America. So these dollars go to a really cool experimental track of cancer research, cutting edge kind of stuff. We're honored to be a part of it. Miguel and I are going to be swimming. And if we raise enough money, Jared himself is going to swim. So Jared, are you excited? Because we're going to raise enough money.
I can't wait to get that nice half a mile swim in. It's going to be awesome. Should I go mile or half a mile? I don't know which one.
I would recommend a half mile. Miguel and I will do the mile. But
okay, good.
I think, yeah. All right, that website is swimacrossamerica.org/go-to/Orenda. Again, that's swimacrossamerica.org/GOTO/Orenda. The links will be below this video. This one is actually on video. Like, we're actually recording this one. We usually do audio only. Second, we are doing a Water Shapes University class at the International Pool and Spa Show. So for those of you in the trade that are thinking of attending the international show, this is not for homeowners. It's only for those in the trade. That class number is WU for Water Shapes University, C3611. And it's the weekend before the show. So it's November 12th and 13th. There's only 60 seats available. So sign up while you can. Hopefully we pack the house. That should be good. And for some reason, they think we're qualified to talk about water chemistry at the level of Water Shapes. Huge honor for us. It's our first time doing it. So we hope to see you there. Today, we're going to dive deep into some science, and I'm going to do my best to simplify it. And I just did a ton of research on it. And both of us are kind of looking at each other, knowing like, we really don't want to do this episode, but it's about the LSI, and we have some standards with our app being the most accurate LSI app in the world. We insisted upon that. We had to factor in borates.
And I'm going to be leaning on you a lot here, Eric, because I know you did a ton of research to get this, not only the blog, but the information out there to our audience. I'm actually going to learn a little bit here today, too, so I can't wait.
Yeah, well, I had a lot of help, so let's get into it. Episode 77, Rule Your Pool. Let's go. Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go. First things first, we're just going to introduce the elephant in the room. We are not pro-borate. We're not really anti-borate either, but we are not pro-borate. As a company, we have taken a stance of you don't really need them. Prior to doing all this research, a lot of this was just misunderstood. A lot of this was not known. Now that I've done the research that I have, and by the way, I'm leaning heavily on 5 main sources, one of which is the late Bob Lowry, who did extensive work on borate. I got to credit him with a lot of it. Richard Falk helped me out, and then I found a whole bunch of peer-reviewed scientific information online. The other sources are pretty much pool sources that regurgitate other stuff. Some of them are just outright inaccurate. So I'm going to cut through the chaff, get right down to just the chemistry, not the opinions, just the chemistry. But I want you to know our position is if you're going to use them, okay, that's fine. It's your practices. We're not here to demonize your practices. We're just saying we don't think they're necessary, but they may make your life easier. They do have some benefits. We're not going to pretend there are no benefits. So just getting that out there ahead of time. We have advocated against using unlabeled borate products in the past. And there have been laws in California, specifically with the California EPA, about which borate products you can use and where you can buy them because of pesticidal issues and herbicidal claims and all sorts of stuff. But we're not here to talk about too much of that. We're going to focus on what borates actually do and their pros and cons so that you can make an informed decision about your own pool, or if you're in the trade, your own pools.
Manage accordingly. That's the bottom line. If you know what you're doing and you know why you're doing it, you can manage it accordingly because you have all the information necessary to make those decisions. That's it.
Right. Okay. We're going to start with one thing, probably more important than anything else. If you decide to use borates, do not exceed 50 parts per million, ever. It's more important than not exceeding 50 parts per million on CYA. There are some toxicity concerns, specifically with dogs. Now, they're not strong toxicity concerns, but the higher you go in parts per million, the more serious it gets. Now, if you stay 50 parts per million or less, there's very low risk. All that research is cited on our website. You can go to blog.orendatech.com, or you can do blog in the main menu of the app and just type in borate. You'll find it. All of this is cited. None of this comes from Orenda. Okay. Jared, what do borates do? What have you heard they do?
I was going to say, I've heard a lot of things, but specifically, they buffer the pH, right? Yeah. And the other thing that I've heard is that they offer an Algaestat-like benefit into the water. So that's it. That's all I've heard.
Yeah, that's pretty much it. I mean, some people will say it's this miracle product that it's like, oh, it's this brand new thing, never used it before. They were actually out in the 1980s. Some people were even using them in the 1970s. So borates are not new. They're just kind of like coming back into fashion.
So that's what I've heard, right? The Algaestat type benefits and the pH buffering. But then the things that kind of throw me off are it can save you 15% in your chlorine usage. And I'm just like, I don't believe it.
Yeah, neither do I.
I don't think the research says that that's a viable thing. Now, can it save something? Sure. But I don't think it's nearly that number.
The main benefit is pH buffering. And I'm going to explain the chemistry of that and how it is kind of yin and yang to the carbonate alkalinity equilibrium that we're used to. And the other thing, yeah, it has some algistat properties to it. Not as much research on that. I looked. There's just not as much information on that. There's plenty on pH buffering, and that's what I really want to lean on here. So basically, borates are a compound of boron, and there are three main borate products that you can get in a swimming pool. Those products are boric acid, then there's borax, which is actually sodium tetraborate decahydrate, and then there's sodium tetraborate pentahydrate. Boric acid is a Lewis acid, and it has something called a conjugate base, and that conjugate base is borate. Now, if you've never heard that term before, it's because we never really dove that deep into the chemistry, but it's important on this because it's different. It's like a mirror image to what carbonic acid and bicarbonate alkalinity are.
Do you have a cool chart that shows this, Eric?
Yeah, we do. In fact, I'll show that chart. That's a good idea because we are on video for this one. So let me share my screen. And for those of you listening, I'm just showing a chart that is available in that borate blog, so you should be able to find it. And what we've done is we've layered the alkalinity equilibrium chart and added the borate factors to it. Now the x-axis is pH. At 4.3, the green line emerges, and that is bicarbonate. The red line starts to come down because they're in equilibrium, and that red line is dissolved carbon dioxide, carbonic acid. It's not technically alkalinity. And its conjugate base is bicarbonate. Where those two intersect at 50-50, that's called a pKa value. You have the most buffering power at that pH. The highest resistance to pH changing is going to be at that pKa value. And for bicarbonate and carbonic acid, that's 6.14.
But don't go there, people.
No, you're not going to get, hopefully you don't get that low. A good way to think about this, if you're looking at the chart, is if you were to staple a kitchen sponge to the right side of that dashed line, so 6.14 up to like 6.5 or so, you got a sponge there. The closer you get to that value, the more resistance in pH you're going to get. You tracking so far, Jared?
Yep.
Now look at the graph and you'll see almost mirror image of it. You have another pKa value, and that's the borate one at 9.2. instead of primarily buffering against the reduction in pH, which is what carbon and alkalinity does, borate actually buffers better against the rise in pH, because instead of dissociating a hydrogen, it actually associates, meaning it attracts a hydroxide or a hydroxyl, an OH. If you got H2O, you split that hydrogen off. What's the other side of it? It's the base. So you've got boric acid, which is the orange line, and its conjugate base is borate.
Okay. So the boric acid, you said, is associating or taking hydrogen.
No. It's taking a hydroxide.
A hydroxide. So it's not taking...
Or a hydroxyl. I should say a hydroxyl, an OH minus. Instead of shedding a hydrogen, like carbonic acid loses a hydrogen to become a bicarbonate, boric acid gains a hydroxide to become borate.
So it becomes borate, but the borate's already in the water.
The vast majority of the borates that are going to be present are going to be boric acid. As you rise in pH, more borate becomes present. And you are going to attach that sponge to the left side of that higher pKa value. So you have two pKa walls with sponges on the inside. So it contains your pH actually really well.
Okay.
I've lost you, haven't I?
No. I'm just trying to process and digest what you just said.
Let's talk about the practicality of what this means. If you use borate, it helps to buffer against the rise in pH. That's basically all it does. It does this by taking a hydroxyl instead of what alkalinity does, which is giving or taking a hydrogen. This gives or takes a hydroxyl. It's just the other side of the equation. Now, technically, they'll buffer in both directions, but really, it's made to slow the rise in pH. But then it comes down to what we talk about at Orenda is containing pH. Do you really need this? Because if you already know where your pH ceiling is, and your pH ceiling is contained to be below 8.2, this shouldn't really apply to you. Maybe it'll help. It probably will help. But is it going to help enough to justify it? I don't know. That's a decision that you need to make.
Clarification here. You're using the word hydroxyl, and I was confusing it with hydrogen because that's what we're doing with the pH change, right? And not the same.
They are not the same. It's the opposite. So H2O, the hydrogen ion leaves. That's what controls the pH, the power of hydrogen or potens hydrogen. And then the opposite side of that, the base of that, is a hydroxyl or a hydroxide.
Gotcha.
Honestly, different sources said it different ways because it'll be like a hydroxyl ion, but some people call that a hydroxide because it's an OH. I could be wrong. I don't know exactly what it is. But if you look at those formulas, clearly an OH is moving. OH is attaching to that boric acid or it is dissociating from it as the pH goes back down. So that's basically what's going on. In terms of the value of borates in the pool, I'd say that's like 95% of why you would use them, is the pH buffering capabilities.
I agree.
Now, there's not a lot of research on the Algaestat claims, but most of the information I was able to find is summarized really well by the late Bob Lowry in his book and the Pool Chemistry Training Institute and all that. He's got some technical bulletins you can find online. And basically what he said was they disrupt algae growth by disrupting cell wall development, metabolism, and cell division. So they don't kill algae. Borates don't kill algae, but they slow their growth, and they make it harder for them to reproduce. So that's an Algaestat claim. I wasn't able to find any concrete units of measurement to say, well, it is 50% less algae growth. There's nothing like that I found. And you would think that there would be in the sources that I read, but no. Then finally, the claim is borates improve water clarity. And that is totally subjective. We talked to Richard Falk about this, and his belief is, okay, it doesn't actually get rid of particles in your water. Filtration would do that. But it does change the surface tension, just like enzymes do. Our enzymes absolutely improve clarity. So does our clarifier. But it changes the surface tension to allow more light in, and it kind of changes how the light reflects in the water. So it can appear clearer when you're looking at the water. That's not necessarily the case if you're in the water, but in most cases, people are finding that the water is clearer, and that's a good thing. So actual turbidity, not so much, but how light reflects in it is what really matters in terms of the sparkle, so to speak. Finally, we get questions about toxicity because it was outlawed in California for many years. Now, what is your perception on why borates were illegal?
Toxicity to animals and small children mainly is my understanding.
Right. I found some studies from the EPA, from the NIH, And basically, you'd have to drink a lot of pool water at 50 parts per million, like a lot more than you possibly would. So it's a very low risk. But if you have high concentrations, like over 50 parts per million, it takes a lot less drinking water to get to that point. And the main concern is with dogs. The real reason that it was actually banned in California, it's not that the products were not being sold in California. It's that they're not being sold in pool stores in California. And as far as I know, they're still not.
But they're still being sold in California, generally speaking, in hardware stores and things like that.
Lawn stores, because you can use boric acid as a pesticide.
So long story short, please just use the products you buy for the intended purposes.
Just make sure that you have something that is officially labeled with dosing information on it, because that's really what matters. You want to make sure what you're buying is the right product for the application if you choose to put borates in your pool.
And the way I look at it, which is the philosophy of our company, if there's risk with this product being overused and, over applied to the water, which could create toxicity issues for small animals and small children, it's not worth it to me. I just don't think the byproducts are worth the benefits that come with it, because like I said, there's other ways to do this that we teach, like controlling the pH ceiling, controlling the chlorine efficiency, chemical efficiency in general, and they don't have long-term byproducts and chemical conflicts, which is our main message here. And that's why we feel the way that we do. So if you want to use it, great. Make sure you know what you're doing and weigh the risk reward. And that's kind of where we fall.
I share that opinion. I'm not knocking the practice. It could definitely make things easier. It'll certainly save you on acid and hopefully bicarb as well. But I don't think it's going to really save much in chlorine. And if it is, it might be getting credit for something that something else is actually doing in your water. But that being said, that's what we know. So if you want more information, you can visit blog.orendatech.com. Just search borate. You can do the same thing in the app, main menu to blog. We'll probably put some more information out there. It's in the app because borate affects the LSI. That's the only reason we included it. That is because it needs to be deducted when calculating carbon and alkalinity, just like cyanuric acid does. If you stay 50 or below, that impact is not necessarily huge, but as you play with the calculator, you'll notice the higher your pH goes, the bigger the impact. If you take borate to 0 and you go up in pH and track how it changes the LSI, that's one thing. Then put the borate up to 40 or 50 and raise the pH, it's a way different equation, because the higher you get, you're closer to that pKa value. You are changing that chemistry, and you have to deduct that at that given pH level to get the carbon and alkalinity to calculate the LSI. Don't worry, the Orenda calculator does all of the math for you. It was a monster equation to do, but it's done. So all you need to do is input your numbers. And I think that's it, Jared. Is there anything else you want to add?
No, I think we covered the main topics with borates.
All right, this is episode 77. Until next time, I'm your co-host, Eric.
You carried this one. I'm going to let you be the host.
Okay, I'll be the host for this one. Jared might be the host for the next one. We don't know yet, but we'll figure it out. Thanks for listening, everyone.
Thanks, everyone.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.